Hey guys, Mr. T here. This is another video. This one is on proof using congruence. So, we've talked about congruence, and if triangles are proven to be congruent, then it follows that, based on the definition of what congruence means, that all corresponding sides and angles in those triangles are equal. So that allows us to use congruence to prove facts or find unknowns in geometric figures where we don't have all the information. So for example, in this figure below, show that AB is parallel to DE. So this is going to use some ideas and facts that are not in this video but should be revision from the topics you've been doing called geometric reasoning. Okay, so we are focusing on congruence here, but it's going to use some ideas from geometric reasoning to prove congruence and then use that to answer this question. So if we look at this figure here, we've got two triangles, okay, so we're going to use that fact, and we know two sides. We don't know three sides. We don't know that AB is equal to DE, so we can't use SSS to prove that they're congruent. We need to somehow prove that these are congruent. Now, we have to use a geometric reasoning idea to show that this angle here is equivalent to this angle here. Why is that? Because in geometric reasoning topic, if you have two straight lines crossing each other, the angles vertically opposite from each other or opposite from each other are always equal. So this angle is going to be equivalent to that, and this angle here is going to be equivalent to that one. And that's the situation we have here. So angle ACB is going to be equal to angle DCE, and we're going to call it alpha. Why? Because of vertically opposite angles. So we've used a mathematical theory to deduce that these angles are the same, and now we have an included angle that allows us to prove these two triangles are congruent. Therefore, triangle ABC is congruent to triangle DCE because of side, angle, side. Because we've got a side that we know, 1 dash, in a corresponding location, another side that we know, double dash, in a corresponding location, and they're on either side of the included angle alpha degrees there. Okay, so we've proved that they're congruent, and because they're congruent, sides and angles in corresponding locations are going to be equal. So if we name these angles, the angle that is adjacent to the double dash, we can call that B. That's going to be equivalent to the angle here, B, and then the angle adjacent to the 1 dash in each triangle, because they're congruent, we'll call C, and that's going to be here, C. Alright. And then we call back to geometric reasoning, because you may remember that if you have two parallel lines, I'll do this in red actually, if you've got two parallel lines and a line going through them, and if the angles here and here are equal, if they're parallel, that means these two angles C would be equal. But we can use the reverse of that. If we found that these two angles are equal, then they must be parallel. Okay? So using the reverse of that geometric reasoning theory, okay? So because angle ABC is equal to angle CDE, and we called it C degrees there, AB, nope, that's the wrong symbol there, AB must be parallel to DE because of the geometric reasoning idea of equal because of equal alternate angles, or the rule alternate angles. Okay, so this is where you can see how little different parts of different topics in maths all flow into each other to allow you to move forward. Okay, that's just one proof using congruence. Hopefully that helps you out, and see you in the next video.